Hi, I am Prerna from Telecom and Technologies, and today I'm going here to discuss about the fundamentals of our 3G systems. So these 3G systems are also featured as UMTS, which is written over here. So 3G, as we know, is the third generation of our cellular systems, third generation of our mobile phone systems. So this is also featured as UMTS, which is Universal Mobile Telecommunication Systems. Now, as we are moving from one technology to another, like from first generation to second generation, and then third generation of our cellular systems. So, this third generation of cellular system was developed and maintained by 3GPP, which is Third Group Partnership Project. So, this is basically a standardized organization which is working towards the development of a global system. So, the basic aim of the development of our third generation of cellular systems or our UMTS networks is to provide higher data rates and good voice services. So, there are very many fundamental concepts in the evolution of this network, the various new parameters which have been inculcated in the new technology. So, today we will have an overview of the architecture of our third generation of cellular systems, which is the network architecture of the third generation of cellular systems. So basically, the network architecture in telecommunications can be defined as an infrastructure which will deliver the services between two end points. So, network architecture of 3G systems. So there are different radio equipments in the architecture or in our network which have been configured so that it can deliver the end services to the various users. So we have the user equipment and node Bs, RNC, so first we will begin with this portion. So these are the different radio equipments which are used in the third generation network system. So first of all, we have the user equipment which is connected to the node B with and radio or air interface. These node Bs are further connected to the next terminal, which are our RNCs, or we can say radio network controllers, connected with IUB interface. So these are basically the interfaces which are used to connect the two different entities in a particular network. So the first major equipment which we have in our system is the user equipment. So we can define user equipments as our mobile phones. So that means this user equipments consist of the mobile phone and the SIM card, which is here referred as the universal SIM card. Now, as we know that SIM card is a subscriber identity module. So, mobile phone is used for the reception and transmission of the radio signals, and the SIM card helps us to register to a particular network of which we want to access the services. So, when this mobile phone and user SIMs are clubbed together, we are able to communicate with our network, or we are able to communicate with various people in the network. So this that means we can say that we, the users, are connected to our network with the help of this air interface. Now, the next entity which we have here in the architecture is the node B. Node Bs are the transmitters, or we can say the reception unit. That means this node B or our base station, this transmitter or receptor unit will receive the signals from the user, or it will also forward the signals to the user. That means if I have to make a call, I have to connect to my serving node B, my base station. It will receive my signals and it will forward the signals to the next particular user in the network, or vice versa, I will receive the signals from my serving node B. So that means the basic purpose of this node B is to connect the users with the rest of the network. That means it is acting here as an intermediary between me, the user, and the rest of the 3G network. So this unit is responsible for the transmission and reception of the radio signals, and this unit is here responsible for implementing the radio access technology. Now, radio access technology is basically an access technology which is used to access the network. Now, previously we talked about the GSM systems. Then, in GSM or our 2G systems, we had TDMA, the time division multiple access, that is the access on the basis of time. Now, here in the 3G systems, we have WCDMA as our access technology. That means this is wideband code division multiple access. Means this access technology is based on coding. So we will access the resources on the basis of the codes. So that means this station here is responsible for allocating the different codes to the users on the basis of which they will be separated in the network. Because we have in this WCDMA systems the same frequency and the time, so users are distinguished on the basis of the codes. So after node B, the next element here is the RNC, which is referred as radio network controller. Now, as its name suggests, radio network controller, that means this entity is held responsible for controlling this access network. This user equipment node B and RNC. This is referred as the radio access network of the 3G or UTRAN, Universal Terrestrial Radio Access Network. So that means this radio network controller is held responsible for controlling these entities. A particular RNC can serve a number of base stations. That means this is the master element which is controlling our base stations. So radio network controller here is responsible for allocating the various radio resources or checking the various radio resources like time, frequency, and codes. So the various parameters of the 3G systems like code allocation, call admission controls, load control, these are the different parameters which are all checked by our radio network controller. The handoff procedure, that means when we are moving from one station to another station, so how our call will be handed to the new station, that all will be controlled by this radio network controller which is controlling our node Bs. Now this part, up to this part, is basically referred as our radio access network. That means this allows the users to connect to the access network. After that, we have the core network, which is the main backbone network. That means it is connecting us to either a PSTN network, public switched telephone network, or either it is connecting us to the internet services. So here I have written CS and PS. So the CS here refers to circuit switched domain, and this is packet switched domain. Now we'll have a look at what these circuit switched and packet switched domain corresponds to. Circuit switch domain or packet switch domains, we can say that these are basically migration from the GSM network. The entities which we will be using here in the core network, they're simply migrated from our GSM network. I have CS domain, which is my circuit switch domain, and the PS domain. So this CS domain is basically responsible for carrying the circuit switch data, or simply we can say that our voice calls. And the CS domain, which is our packet switch domain, is responsible for carrying the packet data. So there are different entities which are used in these two domains so that they can help us to access these services. So first of all, let's have a look at what are the entities which are in our circuit switch domain. In circuit switch domains, we have the same entities as we had in our GSM systems. Like we have this RNC from our radio access network. And if I have my circuit switch domain, so that means RNC will be connected to the entities of the circuit switched domain, which has MSC, or we say 3G MSC. Now this refers to mobile switching center. Now switching center, that means it is responsible for the switching operations, the call establishment, the call management, and transferring the calls to the other network. So this mobile switching center has many databases attached to it. HLR, VLR, AUC, and EIR. This is the main heart of the network because it is responsible for taking care of the mobility management of the network and billing operations of the subscriber also. So the first database which we have is the HLR, Home Location Register, which is here responsible for maintaining the user's permanent profile. Now, if the particular network is my home network, so that means I'm registered to that network. My master profile will be maintained by that particular network. All of the database will be maintained by that. Next is our VLR, which is our Visitor Location Register. Now, if I'm moving from my home network to some visitor network or to some foreign network, so in that network, I also need to access the services. I also need to make the calls. So for that purpose, the VLR is used. That means my file will be temporarily copied to VLR so that it can authenticate me and connect me to the node base or RNC in that network so that the user can access the services. So basically we can say that this is the roaming facility. When we are moving from our home circle to another circle, we are also accessing the services but under the roaming tariffs. So that roaming is enabled because our profile is updated to VLR. Now, after that, we have the Authentication Center and the EIR. AUC refers to the Authentication Center. That means it is responsible for authenticating or validating a particular user. It's maintaining some authentication keys on the basis of which it will check that whether the user is allowed to access the services or not. The last database which we have is EIR, Equipment Identity Register. That means it is responsible for keeping a track of the various valid equipments which should have the access to the network. So the parameter which is used to check the validity or the authenticity of the devices, that is IMEI, International Mobile Equipment Identity. That means it maintains a list like black, gray, and white. So if some of the devices are like stolen, so there is probability that they could be misused. So for that purpose, the black device list is maintaining devices which are totally blocked from accessing the services. Gray will have the list of devices which are denied, and white are allowed to access the services. So that means it will help us to keep the track of the various devices. So these are the various databases were used in circuit switch domains, and this domain is used to make the voice calls. So the next domain is our packet switched domain. That means it is used to provide the packet data. So the entity which we are using here is like RNC will be connected to SGSN and GGSN. So this also been migrated from GSM, or we can say from the GPS. SGSN refers to serving GRS support node, and this is gateway GPRS support node. So that means when the user has to access the data services, he has to be attached to the GPRS service. So this SGSN can be considered as like our MSC. That means I have to access the data services. First of all, I will have to get connected to the SGSN, which will allow the flow of data traffic. After that, we have the GGSN, Gateway GPRS Support Node, which helps us to connect to the external packet data network. If the data is coming from some external network, it will come through GSN, then to SGSN, radio network controller, respective node B, and then to the particular user. So these are the different entities or radio equipments which are used in the 3G network so that the user can access the voice services and the data services. So this was just an overview of the architecture of the UMTS over 3G systems, with the help of which we are able to access the high quality voice and data services.